Slide. There we go. Okay. Hey, thanks everyone for joining, either in person. I appreciate you three for coming. And then everyone else in Zoom land, thank you so much for tuning in. You have tuned in to NextGen Geospatial. So this is the weekly data science workshop series that we do. We try to present to you a new tool or a new concept every week. And most of what we do is generally open source and trying to be a little bit more cutting edge than what you're typically going to see in your accredited classes on campus. So hopefully it's kind of a supplement to your other geospatial education. So today we're going to do something similar to what we did last week. So we are also going to do another lesson on deep learning for aerial imagery. However, we're going to use a different library, a different tool. It's going to be kind of similar, but there'll be some differences, and you will see the differences if you tuned in last week. So let's go ahead and start looking at my course content. Okay. Make sure I put the course content in the chat. Okay, so we run all of our content, our asynchronous content through GitHub. So check out that link if you'd like to look through this stuff on your own time. Okay, so here's a landing page, NextGen Geospatial, AI and cloud tools for geographic analysis. This is the fourth week we've been doing it. Time is flying. Let's go down to the schedule. Okay, so last week we did deep learning using a Python library called Deep Forest. This week, September 24th, we're going to do deep learning, or only we're going to use a library called Detecto. So it's quite similar, but we're not going to be identifying trees in this case. We're going to be identifying different kind of urban objects like airplanes and bridges and cars and stuff like that. Things that are man-made that we might find in that kind of an urban aerial scene. Go ahead and click into my content. Okay, Detecto. So as I'm going through this, please don't try to read the text as I'm going through. More just listen to my voice, and I will highlight things with my cursor if I feel like you really should look at it. So we have about 50 minutes together. Okay, so what is Detecto? Detecto is a Python library. It is specifically for doing deep learning, and it's built on top of Pytorch. And so last week we mentioned what Pytorch is. It's probably one of the two most popular deep learning, or you call machine learning frameworks in the world. There's Pytorch, which was originally developed by Meta or Facebook. And then there's TensorFlow, which was developed by Google. So basically the two biggest tech companies have created these great deep learning, machine learning Python tools that then they've given to us to use. So thank you very much for letting us do that. So Detecto is something called a faster RCNN model. CNN standing for convolutional neural net. So this is a convolutional neural net. It's an interesting data set. It was trained on something called the Microsoft Cocoa data set. You can click in that if you want to see more about what the data set it was originally trained on. But it was trained on over 330,000 images and annotations. And there's 80 different object classes. And so this is not necessarily aerial stuff. This is, we can actually look down into some of the training data. These are just kind of like everyday objects, like a person or a dog or a cow or a car or a motorbike. So originally that's what this was developed for. And so out of the box, Detecto is not going to identify things in aerial imagery very well. It really wasn't trained to do so, but we can train it actually pretty easily to identify, our specific thing that we want to ID. And I'm getting some chats. Anything interesting in the chat yet, Michele?
That was just me posting.
Okay, great. So convolutional neural nets, that is the model that we are using to identify objects. I'm not going to go into the theory, but I have some really great video resources if you're interested in learning more about how CNNs work. So basically the idea is that, yeah, and so instead of trying to identify something from like an individual pixel or grouping things based on, you know, pixels that are similar in some way, we call that object-oriented analysis. We're not doing that. Because I find when you get to high resolution, like from an airplane or from a drone, it's not going to do a very great job of identifying a whole thing, be it a house or a car or a tree or whatnot. When convolutional neural networks came along, it really showed what was possible. And so with CNNs, we are identifying objects that are in a way that's more analogous to how humans identify objects. And so how do we identify an object? We probably look at multiple features, right? If it, let's say it's a tree, how do we know that an object is a tree? Well, we probably in our brain, you know, we're looking at different features of that tree. It might be the, yeah, how do I have it here? You know, the crown, the shape of the crown, or it could be the leaf architecture, or it could be the color. There's all these little bits and pieces of an object that kind of clue us into what the object might be. And our brain does it so quick. Like humans are so great at identifying objects, but it's a lot harder for a computer to do so. So we had to develop convolutional neural nets to be able to a bit more approximate how humans can identify objects. So we're not looking at just a single pixel or a group of pixels that are, you know, clustered. It's a bit more complex than that. So CNN models can take on a few different flavors. They have different approaches to how they identify or classify an image. And there are basically three types that I want to mention. So the first is semantic segmentation. That's not going to work as a highlight. So semantic segmentation is more classically what we do in remote sensing science. We try to take every pixel in the image and bin it, classify it into one of, you know, 4 or 5 classes or something. Every pixel gets assigned a value based on classes that we have kind of predetermined. So that's semantic segmentation. There's something called instance segmentation, where the algorithm tries to identify the specific object and just the pixels that represent that specific object. Okay, be it a tree or a car or whatever. And the thing that we're going to be doing today is object detection. And that's the same thing we did last week with Deep Forest. And so it's going through the images, it's looking for a tree or our specific object of interest, and then it's putting a bounding box around that object of interest. So yeah, so basically 3 flavors of deep learning. Depending on what your question is, you can do semantic segmentation, object detection, or instance segmentation. And Detecto is an object detector. So I did mention that Detecto out of the box is not really going to identify things in aerial imagery very well. But if we give it a data set, we can train it to do so pretty easily. And so the training data set that we're going to use is this thing right here. NWPU, a very high resolution 10 data set. And so you can check the reference if you're interested in knowing a little bit more about where that came from. But it's just kind of a data set that's been out there for a long time that people use for training or for benchmarking. It has 800 total images, and all of these images have objects in them that have been labeled or identified. And those objects are airplanes, ships, storage tanks, baseball diamonds, tennis courts, basketball courts, ground track fields, harbors, bridges, and vehicles. So the goal here is we can take our pre-trained model that we get from Detecto, which is a faster R CNN model. However, it's not going to ID things in our imagery very well from an airplane. And so instead, we fine-tune, train it with this data set here that does have objects from the air. And then after the fact, we hope that we can then identify those objects, you know, based on new images. And so here's an example of what some of the data set looks like. And so it was trained to identify airplanes. So this is what a labeled image would look like. Here's another labeled image of ships. Okay, so that's basically it for the preamble and the theory of what we're doing. Just like last week, we're also going to use a Jupyter Notebook example, and it has pre-written Python code. And so this requires no coding ability or anything like that. All you have to do is open up the notebook in Google Colab, and you can just click along, and it should work for you. So yeah, so before I open the Colab, here's what we're going to do. Yep, so we're going to take our training set that I just described. We're going to fine tune the Detecto model in order to detect those objects of interest, like an airplane or a vehicle or a baseball diamond. Okay, we'll talk a little bit about how you assess the quality of the prediction model. And did I put that? I think I actually left this how to upload your fine-tuned model to Hugging Face. I had that in last week, and I think I didn't quite put that in this week yet. So if you're interested in how to then put your what we call fine-tuned model, how to put that up on the internet for other people to grab it and use it for their own purposes, we use a website called Hugging Face, and the exact Python code is in last week's Deep Forest tutorial. So if you'd like to click along, I would invite you to do so. The easiest way to run this notebook is in Google Colab. And so all I have to do is hit open in Colab, and well, let's pray it works. Again, live demo, folks. So things might not always work as we want them to. Okay, so I'm sitting here in my Google Colab. For those who have never used a Jupyter Notebook, that's what we're doing. This is something called a Jupyter Notebook. It is an environment to write Python code, and you access it and you run things through your web browser, like Google Chrome or Mozilla, or something like that. So that's the simplest way to describe it. And this Jupyter Notebook is being hosted on Google's cloud. And so they provide for free a little bit of resource allocation. They give you a little bit of CPU and maybe a little GPU to do things, and some RAM and a little bit of storage. Colab is great for teaching and training and showing you how things work. But if you want to do something more production or like research oriented and you need more time computing, you should probably check out resources from Cyverse, which was where I work and Michele work. Yeah, or you could do it on your own computer. If you have a big fat processing computer, you can do your Jupyter notebooking directly on your own computer. Okay, so the rest of today's lesson is me basically going to be going through this Jupyter notebook and telling you kind of step by step what we're doing. And so please don't focus on the nuances of the syntax of the code. We don't really have time to dive in exactly why does that code work, or what does that line of code mean. It's more, we're gonna spend more time just thinking about the big picture of what the code is doing, and yeah, what we hope it does. If you're interested in getting more granular about what the Python exactly is, how it's exactly working, we could talk offline or later on. Okay, so I hope some people are with me. Kamel, are you there, ready to go? All right, let me go ahead and connect to my resources. Okay, I just hit that connect button, and now I've got some resources here. I have 12 gigabytes of RAM, some disk space, and I'm using just CPU in this case. So no GPU is enabled. You can get a GPU. In this tab, you can change the runtime type. And here you could click T4 GPU. If you would like to do that, you can. And Google will give you some free allocation to do that, but it runs out pretty quick. And so for today's lesson, I'm not actually going to be doing any heavy processing. I've already like pre-done the fine tuning, and we will kind of skip that step because chances are I will run out of computing resources if I attempt to do it. But you guys are free to do so. Okay, so let's get started. All right, so we're using Detecto, which is a Python library. First thing I do is just want to install it. Okay, now that I have the library I need to and the software, I'm kind of ready to go. Yeah, this next one is I wanted to run the pre-trained model on some test imagery to show you what it does out of the box. So like I said, it should not be very good. It's the pre-trained model out of the box is not really meant to identify things in aerial imagery. And so we can try, but it might be, really bad results. And that's the idea, is to show you what it does out of the box. Okay, so what am I doing in this code block here? I'm bringing in the necessary modules from the Detecto library, and then I'm downloading an image, a test image that I have provided, and then I'm going to run it on a few different little test images. All right, let's go ahead and hit run. Okay, looks like it's downloading my test image. All right, and here, so it ran the pre-trained, out of the box model on aerial images of a parking lot. And if you look down at it, it did put boxes around a lot of cars, but look at the labels. The labels say bottle or cell phone or, a bunch of random things that are not vehicles. So, um, yeah, Detecto is not meant to identify cars from an airplane yet. And so it doesn't have any idea what the scale of those images are. So it's like, our best guess is that it's a bottle. Of course, that's not true. And let's try another one here. Let me go down to the next code block and we hit play or hit run. And this should be a baseball field. Okay, so it identified some things that don't make any sense either. Up here, it thinks that the infield is a person. This big thing, it thinks is a clock. I see train. I see traffic light. Oh, that's interesting. It thinks that like the little icon, the little like pin icon is a traffic light. So yeah, it's not working, but it's not supposed to. Okay, so let's get our training data set. So the data set that I mentioned before, it's got like 800 images, and they include labels of a lot of things: airplanes, ships, storage tanks, bridges, vehicles. And so we're going to click that, run that code, which is going to download that data set. It's a tar file, which is like a compressed file for all those images. Okay, and when you're working in Colab, anytime you download something to your virtual machine, you can see what you have by clicking on this folder. And so yeah, here's what we just downloaded. And here, these two are the test images that I showed you a minute ago. Okay, next line of code is going to decompress that tar file. So we're just gonna get everything out of that compressed file. Okay, got a big long list of images. Great. I'll just make that go away so it's not in the way. Okay, next up is something called Pascal VOC format. So that is about the format of what your labeled or your training data set is in. There's a lot of different ways. Typically, we use text files. But Detecto specifically needs a format called Pascal VOC. And let's see if I can show you what that means. Okay, so I just clicked on one of the uh, currently the label. Okay, so this is currently what that I guess you call it annotation or labeling. The format currently is this thing. It's showing you the pixels for, like, let's say an airplane. So this is like a bounding box coordinates is what this is. Detecto doesn't want the annotation in this format. It would like it in the Pascal VOC format. And so we've got several lines of several blocks of code. All it does is convert that text file into something that looks a little different. And then I'll show you what it looks like when I've done it. So yeah, if you're clicking along, just click run, run, run. Yeah, it's going to create an XML file. Yeah, thank you. Yep. Okay, and then I have to click this last one here to actually create these XML files. Okay, so that should have done it. And if you go into, I believe, ooh, that's interesting. How do I just view that? Can I just view that? If I click it, it downloads. Interesting. That's random. Well, let me try. Open. Yeah, always fine. Okay, doesn't seem like I'm able to navigate this exactly, but it just takes a text file and turns it into an XML file. It looks a little bit different. That's all. That's all the Pascal VOC is doing. Detecto just wants a little different format to understand the labeling and the annotation associated with it. Okay. Now that we have our annotation in the correct format, let's got something called load the training images into data sets. We'll just click that. Doesn't really matter what that means. Okay, so it looks like we have 650 images. It did strip out some that were, I think, negative images, images that were showing you items that we were not interested in. And so we just used the positive image set, which ended up being a total of 650 images to do our training. And so now we are at this code block here. So it's time for us to create a random split of training and validation for the data set. And so this is very typical in most modeling, definitely in remote sensing. If you have a data set, you take a good portion of it to train your model, and then you set aside another portion of it to test or to validate, does your model work? And so that's what this code block is doing. It's doing a random number generator to figure out which ones they should choose. And so 80% of the images are going to be used for training, and the remaining 20% will be used for validation. Let's see if we can see that. The question was, what's the difference between a positive image and a negative image? Okay, so a negative image set is, it seems like just kind of like a lot of random photos that have no labels. Okay, the positive ones are ones that actually have labels. I'd have to dig into this data set a bit to understand why they have them exactly, but we're not going to use the negative image set. I'm not exactly sure what they were doing with that, but we are not actually going to use the negatives. We're just interested in the positives because those are the ones that have the labels and the annotation and the information we need to train a neural net. Okay, so I'm just going to click this code block to split my training and validation at an 80-20 split. Okay, done. And let's look at some of them. Let's have an idea of what some of this training data looks like. Okay, like here's a random photo. And so you can see there are 3 basketball courts. That's what was used for training in this case. I can change this number here to, all, 600 images. So I'll change, let's go to 329. Let's see what image that is. Okay, and those are tennis courts. And so you might see on the image, there's like areas of yellow or areas of blue. You can just ignore that. That's just the color bands of the display using, what Python package am I using? Yeah, there's something there, like the color guns have been switched around accidentally. So never mind the blue and yellow randomness. It's just a visual thing. Let's look at 222. Okay, as a baseball diamond. 213 is a few things: baseball diamonds, tennis courts, ground track field. Okay, so that's just an example of what the training data looks like.
So there is a question from Randall. You know what to do. Unless you want me to figure it
out. Can you paste the
you want me to paste it?
Yeah, just the URL of here, I got it. Try that, Randall. Does that work? Yeah, so the link I just put in the chat is to the today's course content. You then have to scroll down and click on this Open in Colab button. That is how you can launch the Jupyter Notebook and get into the Python code. Does that make sense? Okay, well, I'll just keep going. Okay, this next one is just showing some of the validation data. We looked at training data. Now we're looking at some of the validation data. It looks just the same. It's just going through and showing you all the different objects and their labels, that's in our data set. So that's what a harbor is. Okay, cool. Okay, so we have our training data, and now we're gonna go through like the actual training process. I'm not really going to go into what this is. So this code block just kind of gets things ready. Yeah, it loads the modules that we need to do the actual training, and it specifies the labels. So we are saying that we are in our training data set, we're going to try to identify and train all of these different things, all these 10 different objects. So I'll just hit run. Okay, it did it. Okay, now the next code block is the actual training run. So be careful, because if you hit go, it's going to take a while to do things. And so to reiterate, we are taking our Detecto model, which is a faster RCNN that's been trained on 330,000 images of kind of everyday objects. And we are taking a data set of 650 aerial images to fine tune the model so it can identify things that we are interested in. So that's what this code block does. And so If you hit go or you hit run, it will take a little bit of time on your computer, and I'm gonna actually skip it. Yes, Dan says, hey, be sure you're connected to a GPU runtime. Yeah, that is a good idea. If you try to do this in CPU only and hit run, it will, well, I'm not sure it'll complete. It'll just take a long time. GPU will make things parallel, so you can run the same amount of processes, but across many kind of processing nodes in the GPU, which accelerates everything. It's not necessary to do the training for the rest of the lab. And so the next block I have is, why don't we just bring in the model that's already been pre-done. So this is like a cooking show, you know, where they're like, here's how you make the turkey. And then, oh, look, we have a turkey that's already been made. You know, so that's what we're going to do here because we don't have the time to actually do the training. Let's see if I wrote it correctly. Bear with me a second here and make sure the code makes sense. Yeah, okay. The next step is, we have something in the chat. Failed to assign the backend. Well, Randall, sounds like you need to connect to a CPU or a GPU in your collab environment. But it looks like you actually got to the notebook, which is a step in the right direction. Okay, so I'm going to skip down to here where it says skip the training and use an existing fine-tuned model. Because if you do the training, it could take, I don't know, 20 minutes or something, and you know, don't have time. It took 2.5 minutes. So it's already completed. Oh, nice. Using Google's GPU. Excellent. Okay, well, we have a testimonial that it worked using a GPU and Colab. Yeah, okay, yeah, there's 5 epics. Yeah. Okay, so we have some processor, some training going on right now in the room. I'll just wait a second here. Okay, well, I'll keep going. And so next step is we're going to skip the training because that'll take too long maybe. And we're just using existing fine-tuned model. So I did this training, you know, last week. And so we can just bring that training model into our environment and start testing it. Okay, and so how I'm doing that is with this code block here. And I am getting a fine-tuned model that I created, and it's in my Hugging Face account. So I've mentioned Hugging Face a couple times. You can think of it as like the GitHub of machine learning. And so it's a website where you can post models, or you can post training data sets, or like other things that are related to machine learning, and you can share and collaborate with your friends. Just like kind of like GitHub is used for writing code. And so I take a model, I put it up on Hugging Face, and then I can pull that, you know, right into any kind of coding environment I want. And so I'll just go ahead and hit go. Okay, and so I have my Hugging Face model. Got something in the chat. Okay, thank you, Dan, for helping Randall out. Yeah, T4 GPU is probably the correct selection. Okay, so I brought my fine-tuned model in. So that model should be able to identify things like vehicles and airplanes. And let's take a look. So this code block is going to actually then predict. It's going to look at 4 different images, and it's going to make a prediction, try to identify, what objects are in those aerial images. I guess I should have used GPU also for the prediction. It's the training that takes up usually the bulk of the computing, but the prediction also, if you have GPUs, is going to be faster than CPU only. Okay, I've done my predictions. Now I'm just going to display them. Yep, I should have signed up for GPUs. Let's see how our resources are doing. I currently have 0 compute units available. Well, it's still working, although it's saying I need to purchase more. Okay, so what you're seeing here on my screen are 4 validation images. Right, so these are aerial images that were not used in the model training, and so they are kind of independent, and they are a test of like how good we did. And so this one looks like I found 4 tennis courts. This one found looks like 4 different airplanes. And you see there's a number next to it. That's like a level of confidence. And so it thought it did pretty confidently with the airplanes. On this one, it found a ground track field, basketball courts. This one, it found a bridge, found 3 bridges. Okay, cool. And so, yeah, so we've trained the model to identify bridges and ships and airplanes and athletic fields. All right, let's try it on a few other images. And so I have some random images that I have that did not come from the data set. So I just like went on to Google Maps and I just like cropped out a few images and well, let's see if it works. And so this image is of the Tucson airport. And so this is what the image is. And so you can see we got some airplanes. All right, now let's test if our model can identify those airplanes. Yep, so it's doing the predict, it's doing model.predict, which is, a bit computationally heavy to go through this entire image and identify planes. Oh, okay, it did actually go pretty quick. Okay, and so here are my results. So this is just a random image that I took of the Tucson airport, and it looks like my model seems to be working. It's identifying airplanes, and it's not doesn't look too noisy. Yeah, there's an little airplane here that it seems to have missed. But overall, okay, looks like it's working. Let's try it. Let's try it on a different image. This is an image of that same parking lot. And let's see if it would work on the parking lot. Yeah, it's like when I zoom into it, it doesn't look like it did very well. All the labels are kind of they're like on top of each other. Yeah, I'm gonna need to get like kind of a better validation image than that one. Yeah, it looks like it's kind of all over the place. There's some that say vehicle, but then there's some that say tennis court and baseball diamond and like
One car is not. There's like a group of couple of cars.
yeah,
So,
I need a better tester for vehicles. I don't think that's a very great output. Okay, let's try a test of a baseball field. So this is yeah, baseball or softball fields, down by Keno. So this is Interstate 10 going down here like on the bottom of the image. And let's see how well it did. Yep, it does. It can find the baseball diamonds pretty well. Here's interesting. So it found the entire like the Keno Stadium and it put a big box around it and called it a ground track field. So that's not exactly correct, but it does look like the track and field. So it's not that far off. And what do we have here? Here's some errors. So it found looks like rectangles in the parking lot and called them tennis courts. So that's not right. It also found some, I don't know what those are. Is that solar panels or not sure what those are. Are those covers for parking? But yeah, they called that a tennis court also. So it's not perfect, but it does look like it is working, seems to be most of the time. Okay, go back up and see if there's anything I missed. Ah, yes, there's this big code block. Will this code block work? Probably not. No. This code block would work if you train the model in your collab session. Because I skipped this step and went to bringing in a model that I had already pre-done, it won't work. But if you did the training in your collab session, you should be able to run this thing here. So it is calculating intersection over union, which is a way to kind of assess the accuracy of the object detection. And I can show you what I mean by that. And so back in our course content on GitHub, so this is a very typical way to assess accuracy on, specifically image detection when we are putting a bounding box around our things of interest. An IOU, or a intersection over union, is this equation right here. It's the area of overlap between the predicted box and the train, or the truth box. So it's area of overlap divided by the area of the union, which is all of the area. And so it's just a pretty simple ratio. A perfect accuracy object detector would be a 1. So if you have 1, then you've done pretty good. What is a good IOU, or a good intersection over union, is fuzzy. I've seen 0.5 or 0.4 or 0.6 kind of used as a threshold. Like anything better or above 0.5, we'll consider that, hey, that's a good match. Anything below it, maybe that's a poor match, but that's kind of up to you. And so here's another visual kind of describing the IOU. And so the green box is like, I believe, like the truth, like that's the actual object. And then the pink box is what the prediction was. And so it's not perfect, but it's pretty close. And so that's an IOU of greater than 0.5. And some people would call that a success. And so that's kind of a simple metric you can use in in your assessment. And that code, this code block will calculate that and tell you like how many of your your validation data sets met that criteria of greater than 0.5 IOU. There's a lot of different ways to do, threshold or accuracy assessments. This is just one simple way. Okay, so that's pretty much all the code I wanted to show you guys. Another thing I can mention that I haven't gotten to yet is how we do labeling. Last week I talked about QGIS and how you can do it on georeferenced images, and that's available. Like a tutorial of how to do that is available in the Deep Forest content. If you are doing or want to do labeling in a non-georeferenced images, like all the images we use today did not have coordinates. They were just images, right? There was no, they are images that can't be put into a GIS necessarily. But the program that I've been using is something called Label Studio, which is like I believe an open, free to use tool to do your labeling. I don't have a tutorial yet for it, but that's something I'm working on, and we'll probably post that to this content when I get through it. So yeah, that's a place where you can do your labeling to make your own data set to fine tune Detecto for something you might be interested in identifying. What else? Here's an additional data set that I thought was pretty interesting. So this is a data set that's on Hugging Face. And let's see, what's the description? What's that? Yeah, this computer will reboot in 2 minutes. Michele, my lovely assistant, can you kill that? Okay, I just wanted to show you that this is other data set from satellite imaging. Data set card. Yeah, here we go. Yeah, if you scroll down, it's 2,500 high resolution images with 872,000 labels of a bunch of different classes, vehicles, large vehicles, ships, containers. So it's kind of a similar data set, but looks like a little bit different. And so that could be another data set you could use if you're trying to identify swimming pools. We had that problem last week, or anything else. So Hugging Face is a place where you can find models that exist, or data sets, or other kind of machine learning stuff. And yeah, we are at 2:50, so I'll go ahead and stop here. Be happy to take any questions or comments. Thanks for tuning in.
If you were to run the training on something like Cyber, would it be a lot quicker?
Would it work?
The training, no, would it be quicker, faster?
So the question from our audience was, if we did the training in Cyverse, would it be faster? The fact that you're using a GPU in Colab, it's going to be similar. Cyverse means that you're not going to run out of allocation. Like we have a couple GPUs we could probably help you with, but then you could use them, a little bit more than what Google is going to provide you. But if you really have if you're really doing like a research project, we would suggest you use either the HPC or Jetstream 2. So we could help you with either one of those options. Cyverse is, you can do some GPU stuff, but if you're really have a research that we are really training and stuff, I would not use Cyverse.
Oh.
Okay, let's see here. Dan, do you consider shortcutting the training epochs if the loss was low enough? Even with the GPU, it takes a long time. Yeah, so Dan is talking about the epochs, which is like the number of times you cycle through all the data. And in the Jupyter notebook, there's actually a graph that you output called loss, which just shows kind of like your progress, or how your model is getting better or not getting better through all of the epochs. And so let's see. Do you consider shortcutting the training epochs? Yeah, I would. So Dan is saying that it's taken a long time to do this, even with GPUs, and that I often will start with like a few epochs, maybe 2 or 3. Yeah, thank you, Travis. Yep, as you can, Travis is showing here. if you look in the chat, he posted an image. I'm not sure. Can people see that? No, I don't think people can see that. Yep, he's showing that the losses kind of levels off after a while. And so it makes sense after about 5 epochs to not do anymore. But I usually start with a couple and see how it does, and then, build more and more. Dan was suggesting that, yeah, the improvements after about the 4th epoch are minimal. Yeah, that is true. Yeah, the number of epochs is something I'm continuing to understand, but yeah, I usually start small. 10 is probably going to be overkill for most things. But yeah, thank you for the comment, Dan. Okay, any other questions? So I hope today was just kind of a gentle way to get into deep learning. We didn't get very deep into it. There's a lot of nuance when you're using things built on Pytorch. But the idea is that it's not that hard to get started, to use a library like Detecto. It makes it pretty simple to get going. Yeah, this is just a good introduction, and basically take it from here. So yeah, please reach out if you have any additional questions or thoughts, or if you want to tell me about your deep learning experiences. I'd love to hear. I'm continually learning, so me giving these workshops is how I am learning the topic myself. So this is a work in progress for me as well. So, well, thank you guys. You have a question?
HPC stuff.
Okay, we'll save that for another time.
So, I mean,
Okay, thanks, guys.